Today we're doing systems of linear equations in two variables, which is just a fancy way of saying we're solving by substitution or elimination. The day before we solved by graphing, you found the point of intersection. Now we're going to do substitution or elimination. I know a lot of you already remember how to do those two things, and so once you see the problem, if you want to pause the video, try it on your own, check your answer, totally do it. So we're going to solve this first system by using elimination. In order to eliminate, that means we're adding or subtracting the equations from each other, and they have to either have the same number in front of P or the same number in front of Q. So you could either multiply this first equation right here by 3 or multiply the second equation here by 2. I'm going to multiply the second equation by 2 just because I think that's going to be easier personally, but if you want to multiply by 3, do it. Okay, so I'm going to multiply this guy by 2. So what I have is 3p plus 2q is equal to negative 2. I just rewrote this first equation down here. And then the second equation is going to become 18p minus 2q is equal to negative 12. So I'm here, and I realize my q's have the same number in front of them, and I can just add these two equations together, and my q's are going to disappear. 3p plus 18p gives me 21 p's. My q's disappear because 2 minus 2 is 0. And that's equal to negative 2 plus negative 12, and that's negative 14. So then I'm dividing both sides by 21. I end up with p is equal to negative 14 over 21, which is really negative 2 thirds. So now I have to take what I found for p, plug it back into either equation so I can figure out what in the world q is. So I'm going to take this guy, oopsies. I'm going to take the first equation. So I'm going to take 3 times negative 2 over 3 plus 2q is equal to negative 2. And we are going to solve. So then when I multiply those two things together, I end up with just negative 2 plus 2q is equal to negative 2. When I add 2 to both sides, they disappear. So q is equal to 0. So when I do substitution, I end up with the point negative 2, comma, oh, this was elimination, just kidding. So when I do elimination, I end up with the point negative 2 thirds, comma, 0. So substitution, which is what I was talking about. So substitution is when I get a variable by itself, and so luckily this equation already has d by itself, and I take everything d is equal to and plug it into the second equation, n for d, and we're going to solve. So I have 1/2, instead of d, I'm writing that 2 minus 6c, minus c is equal to 1. When I distribute that 1/2, I get 1 minus 3c minus c is equal to 1. I'm then going to subtract 1 and combine my c's all in one step. Hopefully I don't freak you out. So I have negative 4 c's, and when I subtract 1, I get 0. And c is equal to 0 when I divide both sides. So now I'm going to take 0 and plug it in. I think I'm going to plug it into this one. It looks like it's going to be the easier one to use. So I'm going to plug it into d is equal to 2 minus 6, and in parentheses 0, because that's c. So I now have d is equal to 2 minus 0, and 2 minus 0 is equal to 2. So the intersection of these two lines is the point 0, comma 2. And there is substitution. Sometimes elimination will be easier to use, and then sometimes substitution will be easier to use. It just depends on the equations that they give you. Okay, now for the try it on your own. I gave you this crazy version because there's a version like this at the end of your practice. So I'm going to start you off and try to set everything up for you, and then I want to see what you can come up with. Okay? So try on your own. We're going to solve the system, either substitution or elimination. That's going to be on you to choose. This says to let x equal 1 over u and y equal 1 over v. We're going to rewrite these two systems in terms of x and y and solve. So right now how these are written, we can't solve them. Then we're going to use what we get for x and y to find u and v. So once you find x and y, you're going to use these guys again to help you figure out what u and v are. Okay, so I need to rewrite these systems in terms of x and y. If 1x is equal to 1 over u, then 6 over u is equal to 6x. And then if 1y is equal to 1 over v, then a negative 2 over v is going to be equal to a negative 2y, and it's equal to 1. Same thing with this guy down here. If I have 3 over u, then that means I have 3x. If I have 4 over v, that means I have 4y. These are the equations that I want you to solve using substitution or elimination. So figure out what your x is, figure out what y is, and then I want you to try to convert it back so you can figure out what u is and what v is. Just try it. Good luck.